smoke stream. I'm sorry for that slide. So first of all, to an outline of the presentation. We've had an introduction with how smoke is forming, the principle of what we see, and the trajectory of the stream. Also, we've had a theory with the estimation of velocity, although I have to say there were 3 fit parameters, so I'm not really sure how accurately that formula could work, and about the smoke motion stages, but only quantitatively, I have to say. So about the experimental observations, she had several parameters in there which I really liked, such as the diameter, the number of layers, the length of the tube, and the jar volume, which I really think were crucial parameters, and it was really good that you mentioned them. Thank you. And so there were several strong and weak points about the report. I'm sorry, it looks bad if it's not coming at the beginning. I'm really sorry about that, because actually I liked your report. There were several parameters included, such as the density of the air, temperature, pressure, number of layers, and the jar volume, as I already explained before. But however, at the temperature, I was not quite sure what you are standing for temperature that's constant or not, because in the end you had the influence of turbulences, and you were saying it's about non-constant temperature, and I wasn't sure about that. Also, you have done great experiments with the observation of the principle, and you varied the tube as well as the jars. I'm sorry we forgot that here. So there's also the theory where you determine the velocity, and you've also had the quantitative explanation of what is happening. However, there wasn't mentioned anything like the smoke density. It would have been really interesting as the smoke is flowing on the bottom, so this would have been important. And also the smoke composition, you weren't talking about it, if it's incomplete combustion, which is down here, and also about the amount of smoke. And you've missed some experiments such as temperature measurements, pressure measurements, and velocity measurements, because that would have been crucial to the task. The theory didn't include mathematical description of the air drag, several parameters that I mentioned, and incomplete combustions and the turbulences. And the formula had 3 fit factors, so I'm not sure with 3 fit factors you can fit like nearly everything. And then you had the discussion with the influence of pressure, constant temperature, the air drag and trajectory, and the influence of layers, which was really great. To the opponent, I loved your discussion actually, because you mentioned important things such as pressure, temperature, and layers, and you were talking about the hermetical jar, as well as you were talking about the quantity. However, you asked why smoke is burning. I was really insecure about that question, like why should smoke ever burn? And you didn't ask about several measurements, which would have been really important. But all in all, I loved the discussion and the report especially. Thank you very much. Thank you.
And now it's time for the concluding remarks from the report.
Okay, at first I want to thank to the Twitter opponent and reviewer for asked questions, for the discussion, and for the floor for my presentation. But as a matter of fact, I have some remarks, such as I told about changes of pressure, why it is constant. We took a really small volume and took a big tube, and if pressure is changed, the smoke stream must stop, and that's why I think that pressure doesn't change in our experiment. About measurements of temperature, we try to measure the temperature, but we can't make it very precise. That's why we don't include this into our report. About the constant temperature, I told that we use only simplification for calculation. I don't told that that we have constant temperature inside our tube. I told about temperature distribution, but for simplification model, we took these approximations. About velocity measurements, I measured the velocity the way I can. About density of the smoke, we may only estimate, and from the photos we can say if it is more dense or less dense. About the composition of the smoke, we don't interested in chemical reaction because burning of paper is really difficult process. That's why we can't say about any composition because there are many of substances inside it. As a matter of fact, that is all. Thank you for your attention.
And now it's time for questions and answers.
Student President, you asked where the difference when it was covered with cellophane and the experiment where it wasn't. What is the difference in your opinion?
Well, in my opinion, it would be mainly about laminar,ity or turbulence of the flow inside of the jar itself. Because if we have an open jar, the air can flow inside and somehow make it worse for us who clearly see the flow itself. It makes many of the calculations or exploration itself worse.
To report if the smoke is coming into the jar which is covered, where does something has to come out from?
Could you repeat your question? I don't hear anything.
Yeah, sure. If some air is or smoke is coming in from the pipe to the box which is covered with cellophane, where something has to come out, I mean it's covered. Where does this air come out from?
I don't think that, as I told, there is no airflow somewhere inside the jar. I think the pressure is constant, and we can somehow deformate our cellophane, and of course there's some amount of oxygen from the jar is burned. That's why I think that was no airflow outside.
So it's a deformation of this cellophane.
Can you also speak louder, please?
Well, I'm pretty sure then from the videos that the flow flowing outside from the tube is turbulent, and the flow inside the tube I can't really determine, but I would say that it's laminar inside.
I disagree with opponent. I think that our mostly at the beginning of the process is laminar, but at the end of the process it becomes turbulent. Because we don't see any roughnesses of our smoke stream. It is quite straight and it's quite laminar. And inside the tube we don't look into our tube to be sure that the flow is exposed.
A follow-up to this question about the deformation of the cellophane. So does it go, bulge, or does it deform inward?
We don't see any deformation, but I think that some changes of pressure can be neglected because of deformation. But in fact, this deformation can be very, very small. But we don't see this
I
deformation.
didn't see it in experiment. What is that?
Well, we really couldn't see deformation, but if the opponent's reference statement that the pressure doesn't change is true, it needs to deformate.
No deformation.
Well, we didn't see any.
I say it does deformate because there is something flowing inside.
So
So
it bulge
this
or-
change, yes, it's supposed to go outside. However, you cannot see it because the jar was too big to actually see the deformation.
Okay.
I understand that the reporter hasn't seen anything inside the tube because it doesn't have a looked inside the tube. But any of the other two found some interesting phenomenon inside the tube?
Actually, if I'm allowed to say that now,